Good day. 85 non-equivalent reacting amounts. In the previous video we did question 1, and now we're going to do question 2. And it turns out to be quite a crazy question in terms of the wording. So we're going to try to straighten that out. What we have is we've had a spill of hydrochloric acid and nitric acid. And for lab safety, if we spill acid, it's typical to add sodium bicarbonate, a weak base, to neutralize it. If we had spilled base, we would add vinegar to it, but that's an aside. So what this means is we're going to have to get our moles of base from the sodium bicarbonate, and we're going to have to get our moles of acid by totaling the moles of hydrochloric acid and nitric acid. And that's what we're going to do right now. So here's our HCl given a volume concentration, our total moles there. We do the same thing for the nitric acid. And we take those two sets of moles and we add them together and we go 5.50 moles. Now you say, why would I write down Ha? Well, that's our generic formula. If we have a mixture of acids, we're just going to call it HA, and that'll be fine. Now we have to do our base. And our base involves sodium bicarbonate here. And we have to take our 450 grams and we have to divide it by the molar mass of sodium bicarbonate, and we get 5.4 moles here. Now, having done that, we need an equation. So we take our acid, HA, we add it to our base, HCO3 minus, and we make H2CO3 and A minus. And in titration, once we have our balanced equation, and we see it's 1:1, we really don't care about the products after that. So here are our actual moles. Now we look at the moles reacted. We take the smaller amount, it's 1:1, so all the 5.4, all the base gets used up, and we're going to have an excess of the acid. So we get 0.1 moles in excess, remembering our stoic limiting excess from last year. We have to divide that by the total volume that we have, which happens to be 2.5 liters plus 1.5 liters. So we divide it by the 4 liters and we get 0.025 m, and we take the minus log of it and we get a pH of 1.6. So even though we're really close to number of moles, it's still strongly acidic. And if we add just a little bit of more sodium bicarbonate, it should neutralize and get it to that pH of around 7 fairly soon. But anyways, if you look at that question, it was weird wording. Hopefully this makes a fair amount of sense. And carry on with lots of titration fun.